Do you know how chemists check whether an oil is fresh or spoiled? It is by determining the acid value of the given oil. Welcome back students, I am Dr. Swati, your organic chemistry coach. So in this video, I'll be explaining about acid value. What is acid value? What is its significance? And how we can determine acid value to decide the purity of the given oil or fat sample. Stay with me till the end of this video because this is one of the most important analytical constant of fat or oil. Now let's jump into the topic. Acid value is the number of milligrams of potassium hydroxide required to neutralize free fatty acids present in 1 gram of oil or fat. The fats or oils are nothing but triglycerides. That means they are the esters of glycerol and fatty acids. Sometimes they may consist of free fatty acids as impurity, which may be responsible for the adulteration or rancidity of the fat or oil sample. So the purity levels of the given oil sample can be checked by determining the free fatty acids available in the given oil sample by performing acid value determination. The free acids which are available in the fat or oil are chemically acidic in nature. Hence, they are determined by titrating with base such as potassium hydroxide in the presence of a suitable pH indicator. Then the free fatty acids react with the base and they give corresponding potassium salt of that acid. So this is how by performing an acid-base neutralization titration, we can determine the acid value. Now let us see the significance of acid value. By determining the acid value of the given sample of oil or fat, we can identify the purity of oils and rancidity can be identified. Rancidity is nothing but unacceptable odor or taste of the oil or fat. So this rancidity may be arising due to hydrolysis or oxidation during its storage conditions. So in that way, even the storage quality of the given sample of oil can be determined by performing the acid value. And thus, if the given oil or fat is having desirable quality, then it is suitable for the pharmaceutical application. And thus, suitability of the given sample for the pharmaceutical application can be identified with the help of acid value. Higher the acid value, more will be the degradation. That means if an oil sample is not stored properly, then usually it will be having higher acid value. This indicates that the given sample is a stale oil or it is stored under improper storage conditions. Now that you have learned about the definition and the significance of acid value, now let us see how we can determine this acid value. So step 1 is dissolve the given sample of oil in a solvent. So here basically fats or oils are triglycerides. They are the esters of glycerol and fatty acids. And these are usually water repellent in nature and they are soluble in only organic solvents. So it is because of that reason. So as soon as oil sample is taken as per the monograph specifications, then it should be dissolved in a solvent system which consists of mixture of equivalent amounts of ethanol and ether. One of the important key point here is we are going to analyze the free fatty acids available in the given sample. If any other components or solvent systems we are using in the titration, they should be devoid of acidity. That means whatever the other components or reagents that we use in this titration, they should be neutralized solutions. So in order to ensure that a neutralized solvent system is used, that means here the solvent system should be neutralized first before it is used for dissolving the oil sample. So step 1 is more or less like sample solution preparation. So this sample solution we will be taking in the conical flask. Now in step 2, we will be adding phenolphthalein indicator. Step 3, titrate the reaction mixture against 0.1 molar potassium hydroxide till we get the end point. Now we are titrating with potassium hydroxide means potassium hydroxide should be taken in the burette. So when we start titrating with potassium hydroxide, then the free fatty acids which are available in the given sample, they react with potassium hydroxide and they give corresponding potassium salt of the acid with the formation of water as the byproduct. Thus, the principle involved in this acid value determination is acid-base neutralization titration. Now, we have to continue the titration by using potassium hydroxide till we get the end point. Now, what is the end point in this particular reaction? It is colorless to pale pink color. Because at the end point, slight excess of base will be left over in the conical flask and the color of phenolphthalein in the presence of basic environment is pale pink color. So, appearance of pale pink color in the conical flask indicates the end point of the reaction. Then once endpoint is reached, then note down the volume rundown and substitute this volume rundown in the formula which is given for the acid value determination. Now this is the formula used for the determination of acid value. So acid value equals to V multiplied by 56.1 whole divided by W. So here V is nothing but volume of potassium hydroxide rundown. That means whatever the potassium hydroxide we take in the burette, that volume rundown is V, and W is the weight of the oil sample. So each and every sample, how much of quantity that we have to take, this particular information will be provided in the monographs such as IP, BP and so on. So accordingly, we have to weigh the sample and dissolve in the solvent system. Now here a numerical value is given, that is 56.1, which is nothing but the equivalent weight of the potassium hydroxide corresponding to 0.1 molarity. So theoretically, all the literature consists of this particular formula, but practically when you are doing this acid value determination, we have to consider even the molarity of potassium hydroxide used during the experimentation. So in that case, we will be utilizing this second equation where acid value equals to V. V is same, that is the volume of potassium hydroxide rundown. So which is multiplied by 56.1. This is common. Now this whole numerator should be multiplied with M2 whole divided by W. W is the weight of the sample and which should be multiplied with M1. Now we'll see what is this M2 and M1. So whenever you are doing standardization of potassium hydroxide along with the determination of acid value, whatever the molarity value that you are going to get under standardization of potassium hydroxide, that is the actual molarity of potassium hydroxide used. So which is denoted as M2 here, so that you will be substituting in the numerator. Now, as per IP specifications, we are supposed to use 0.1 molar potassium hydroxide. So this 0.1 is nothing but the standard molarity of potassium hydroxide, which is denoted as M1, which we are supposed to substitute here in the denominator. So M1 is here 0.1. So this is how an additional molarity term we have to use when we are going to determine the acid value practically. So lower the acid value indicates the better quality of the given fat or oil sample. So this is how, by performing the acid value, we can identify the purity and quality of the given oil sample. So I hope from this you might have understood the definition, significance and determination of acid value, which is one of the most important analytical constant based on which the purity of oils can be decided. If this video is useful to you, then give it a like and subscribe my channel so that you won't miss my next coming chemistry concepts. Thanks for watching and stay tuned to my upcoming videos.